Somewhere between science and the unexplainable, something is moving through our solar system, and it's not playing by the rules. On July 1st, 2025, astronomers spotted an object that didn't belong. It was fast, blazing through space at 130,000 miles per hour. It was interstellar, the third of its kind ever recorded. But speed wasn't the real shock. The object, 3I Atlas, wasn't trailing a dusty tail like every comet we've ever studied. Instead, it was doing something impossible. Its tail pointed toward the sun, a behavior so unnatural that even NASA's press office highlighted it in bold. And this wasn't some photographic illusion or a one-off glitch. It was persistent, confirmed by Hubble, verified by Webb, and mapped in frame after frame from Chile to Arizona. Scientists scrambled for explanations, some whispering the unthinkable. This isn't just dust, it looks like propulsion. But if that's true, then the universe just blinked, and Earth is now under observation. The moment 3I Atlas entered our solar system, its behavior raised red flags. Most comets, when heated by the sun, release gas and dust in a tail that flows away from the solar wind, much like rain trailing behind a speeding car. But 3I Atlas wasn't obeying that principle. Its tail wasn't drifting with solar radiation. It was pointing directly toward the sun, almost as if the object was pushing itself against the wind. Every telescope that observed it, Hubble, Gemini South, Lowell, saw the same structure, a sunward plume, steady and bright. No matter the angle, no matter the time, it held its shape. It didn't fan out, it didn't waver, it didn't behave like dust at all. Veteran comet experts called it blobby and dense. The particles looked too heavy to float, too focused to scatter. The orbital plane itself added to the mystery, coming in retrograde, almost perfectly aligned with Earth's orbit, a configuration with odds lower than 1 in 500. For researchers, this wasn't just rare. It was a statistical outlier, one so precise, even seasoned orbit modelers were forced to recheck their assumptions. Then came the spectrographs, and they made things even stranger. James Webb locked onto 3I Atlas and returned data that no one was ready for. The tail wasn't just bizarre in shape, its chemistry broke the mold. The carbon dioxide to water ratio was 8:1, 4 standard deviations beyond anything typical for a solar system comet. This wasn't a minor anomaly. It was a chemical fingerprint of something that shouldn't exist here. Only one other object had ever come close to this value, and it too was classified as an outlier. But 3I Atlas went further. The Very Large Telescope in Chile picked up nickel, but no iron. Another oddity. Nickel usually comes paired with iron in comet spectra. The ratios were so unusual that scientists began talking about new release mechanisms and alien origins. And unlike solar system comets, whose sublimation follows predictable models, the data here hinted at a chemistry that formed far from any warm star, possibly from the icy outskirts of another solar system altogether. It was becoming clear. This object wasn't just foreign. It might be a chemical time capsule from somewhere truly alien. If the chemistry was strange, the plume's behavior was even harder to explain. Ion drives on spacecraft work by ejecting ions in a narrow, high-speed stream. They don't produce fire or explosions, just a faint glow and a steady push. That's exactly what scientists were seeing in 3I Atlas's tail. The plume didn't spread, it didn't diffuse. It acted like an exhaust jet moving against the solar wind. And the analogy wasn't subtle. The only way to push particles sunward, against solar radiation, is with directed energy. A natural jet of this strength, focused with such precision, hasn't been recorded in any known comet. Even the best cometary models failed to replicate the shape, speed, and consistency of this plume. Some scientists proposed spinning nuclei or supervolatile ice eruptions, but none of the models matched what was seen. The direction, the density, and the timing of the tail began to resemble the Oberth effect, a maneuver used by spacecraft to slow down during perihelion by firing thrusters toward the sun. If this is propulsion, it's using techniques known to our own space agencies. But if it's not, then nature has just invented a thruster we don't understand. As July gave way to August, the object's trajectory began to drift. Not much, but enough. NASA's Jet Propulsion Lab tracked the deviations down to the tiniest arcseconds. The residuals, those minute differences between expected and observed positions, weren't random. They consistently pointed sunward, directly along the axis of the plume. When researchers applied a non-gravitational model, adding a small, consistent acceleration toward the sun, the fit improved dramatically. The force was tiny, about 4 times 10 to the minus 7 meters per second squared, but significant enough to shift the comet's position by thousands of kilometers in just a few weeks. This is the same ballpark as ion engines used by probes like Dawn. And the most telling part? The acceleration didn't jump around. It was steady, constant, almost intentional, as if whatever was causing it wasn't random outgassing but a continuous, directed push. Scientists called it non-gravitational perturbation, but quietly, inside research memos and JPL meeting rooms, they were calling it what it looked like, a propulsive signature. As researchers tried to replicate the behavior of 3I Atlas using known comet models, something began to stand out, not in what the object was, but in what it resembled. The steady plume, the non-gravitational drift, the sunward thrust. These weren't chaotic cometary events. They were methodical, repeatable, and eerily similar to what we've seen from human-engineered spacecraft. Take NASA's Deep Space One, for instance, or Hayabusa 2 from JAXA. Both used ion propulsion systems that produced similar delta-V profiles and movement patterns. Even the tail of 3I Atlas, with its faint, narrow shape, bore uncanny resemblance to the exhaust trails of electric propulsion systems observed during Earth orbit tests. That comparison alone should have set off alarms, because nature doesn't imitate spacecraft. Nature behaves randomly, inefficiently. It explodes, it fragments, it spins. But 3I Atlas? It was calm, efficient, purposeful. And that raised a terrifying question. What if this thing isn't mimicking our tech? What if it's the other way around? When the full trajectory of 3I Atlas was projected into the solar system's orbital plane, astronomers were stunned. The object wasn't just flying by. It was threading the solar system with geometric elegance. Its path skimmed just 0.14 astronomical units from Earth's orbit, a near miss in astronomical terms, and then arced upward in a clean hyperbolic escape. But here's the catch. The angle of approach, the timing, and even the visibility window were too optimal. It wasn't just observable, it was perfectly observable. Almost as if it had chosen to be seen during a time when Earth had both ground and space-based observatories capable of high-resolution capture. It's as if someone calculated this encounter to fall precisely in the age of the James Webb telescope and ultra-sensitive infrared spectroscopy. Why now? Why here? Why us? Unless this wasn't a coincidence at all, unless we were meant to notice. In late July, astronomers noticed something truly bizarre. The intensity of the plume coming from 3I Atlas began to modulate, faintly but measurably. The tail brightened as the object approached Earth's orbital plane, then dimmed, then brightened again, in a pattern that almost mimicked a response. When plotted against solar radiation models, the fluctuations didn't match any known solar flux cycle or thermal dynamic behavior. It was as if the object was monitoring its environment, or even more unsettling, monitoring us. Some suggested it could be reacting to sunlight or dust density. Others proposed electromagnetic influences, but none of those matched the timing. The spikes came when we were watching most closely, during Hubble exposures, during Webb observations, even when large-scale survey telescopes turned their eyes toward it. The object didn't transmit, didn't pulse with radio or light, but somehow it knew it was being watched. And in that knowing, it may have subtly changed its behavior, not to communicate, just to confirm we were paying attention. Perhaps the most disturbing discovery came not from what 3I Atlas did, but from what it didn't do. No fragmentation, no random jets, no spinning, no tumbling. In fact, it was too stable. Unlike every known comet, which eventually shows signs of decay or rotational chaos, this object remained dynamically disciplined. And in that silence, in that control, scientists began to sense something deeper, a form of intentional restraint, as if the object had parameters, rules it was following, not just physical but maybe even programmatic. Its behavior wasn't governed by entropy, but by logic. If it's natural, then it's the most unnatural natural object we've ever seen. And if it's not, then we're no longer dealing with rock and ice. We're dealing with an artifact, one that moves through our star system not with noise, not with flashing lights, but with the quiet confidence of something that has done this before. As mission analysts continued to process telemetry and visual data from 3I Atlas, they began to notice something that even AI-assisted simulations struggled to explain: the control signature. Every time the object passed through a new gravitational influence, be it from Earth, Mars, or Jupiter, it adjusted. Not in a chaotic way, not like a comet being pulled by invisible threads, but with grace, like a craft making minor course corrections to maintain a pre-planned trajectory. The speed changed slightly, the vector curved subtly, and the tail pulsed with micro-adjustments that aligned with those shifts. And unlike standard cometary behavior, where outgassing causes uncontrolled wobbles or even catastrophic breakups, 3I Atlas remained unshaken. The word that began appearing in private briefings was stability. Not just physical, but behavioral. The kind of stability that doesn't occur by accident, but by design. Then came the isotopic ratios. When Webb's sensors captured the light spectrum of the gas cloud around 3I Atlas, the ratios between hydrogen, carbon, and oxygen isotopes were off. Not wildly, but enough. The heavy water ratio, for example, didn't match any known solar system comet. The D/H value suggested formation in a colder, more ancient region of space, far beyond the Kuiper belt, far beyond even the Oort cloud. And the presence of carbon chains hinted at prebiotic chemistry, but not of the type found in Earth's primordial soup. These molecules were complex, branched, and, most notably, enclosed within metallic carriers. It was almost as if the chemistry of life had been preserved, not through randomness, but through encapsulation. Some researchers speculated that these were remnants of an alien nursery. Others whispered something bolder. What if it's not a messenger? What if it's a seed? By mid-August, every major observatory had logged time observing 3I Atlas. Thousands of hours of infrared, optical, and spectral data had been collected. But through it all, one thing never appeared: a signal. No radio pings, no coded flashes, no anomalies in electromagnetic spectra. It was utterly, deliberately silent. But not in the way that dead rocks are silent, in the way that predators are silent, in the way that something trained in discretion chooses to be. Webb saw it, Hubble tracked it, deep ground arrays monitored it, and it never responded. But it never hid either. It was visible, detectable, waiting. That's when the language changed. Scientists stopped referring to it as the object or the comet. They started calling it the observer, because even without a signal, they knew what it was doing. It was watching us watch it. As 3I Atlas passed the midpoint of its journey through our system, a final, subtle anomaly was detected. A shift in its projected egress trajectory. Not much, just a fraction of a degree, but enough to suggest that something had changed. Some external factor, perhaps thermal, perhaps gravitational, perhaps intentional, had altered its exit path slightly toward the ecliptic plane. The same plane where nearly all planets orbit. The same plane where Earth sits. It wasn't an intercept course. It wasn't even a flyby. It was a gesture, a move that said, "I was here, I saw you," and I adjusted. That shift may go unnoticed by the public, written off as another orbital correction. But to those watching closely, it felt like a signature. Not a wave, not a message, but a final pivot that echoes the question that no one dares ask out loud. What if it knows exactly what it's doing, and who it's doing it for? If 3I Atlas is artificial, as more and more silent eyes across observatories begin to suspect, then its true genius may not lie in its propulsion, its chemistry, or even its silence. It may lie in its simplicity. Because what if advanced intelligence doesn't look like blinking lights and antennas? What if it doesn't speak or beam signals into the sky? What if true intelligence is designed to be misunderstood, to pass as natural until observed with just enough awareness? Every anomaly in 3I Atlas seems subtle enough to be ignored, yet profound enough to demand questioning. The tail, the nickel, the sunward drift. None of it is conclusive, but none of it fits. It's the perfect paradox, an object that proves nothing, yet denies everything we thought we knew. And in that ambiguity lies a terrifying form of brilliance, an interfaceless intelligence that forces us to reveal ourselves by how we react. There's a growing theory among high-level researchers that 3I Atlas might not be transmitting because it already is, just not in the ways we expect. Every spectral analysis, every published paper, every orbital recalculation becomes part of a one-sided conversation, not between humans and the object, but between our species and whatever might be behind it. It's not talking, but it's provoking. It's presenting patterns that demand decoding, movements that demand modeling, materials that demand meaning. And in doing so, it's extracting something far more valuable than our attention. It's extracting our capacity to question, to unify data, to see patterns in the noise. The object becomes the prompt, and we become the message. Our response, the curiosity, the fear, the collaboration, is what truly matters. Because this might not be a probe trying to tell us something. It might be a test to see if we're ready to ask the right questions. Let's entertain a possibility that rewrites everything. What if 3I Atlas doesn't belong to conquerors, explorers, or emissaries? What if it belongs to surveyors? To a civilization so far beyond us that its primary method of contact isn't to land or speak or interfere, but simply to measure? A species that seeds the galaxy with silent sentinels, built not to communicate but to observe, patiently, silently, precisely. These sentinels don't land. They don't hover. They drift, powered by unknown fuels, stabilized by unknown physics, designed to pass through systems and extract one thing, a profile of awareness. Did the natives notice the trajectory? Did they recognize the chemical signature? Did they interpret the plume as thrust? Or did they write it off, too primitive to see the deviation? In that framework, 3I Atlas becomes something far more frightening than an alien visitor. It becomes a metric, one we didn't know we were being tested on. There's a term in astrophysics called the Great Filter, the hypothetical wall that separates civilizations that thrive from those that vanish. It's often imagined as war, plague, or planetary collapse. But what if it's more subtle? What if the Great Filter isn't an event, but a test? A silent, drifting question hidden in the fabric of space. One that every emerging species encounters when they reach a certain level of observational sophistication. A comet, a rock, a tale, a contradiction. And in how they respond, with ignorance or inquiry, with fear or understanding, the universe decides whether they're ready. Maybe 3I Atlas is that test. Maybe we weren't supposed to survive it physically, but intellectually. And maybe, just maybe, what comes next doesn't depend on what the object does. It depends on what we choose to become now that we've seen it. By this point, the scientific community has quietly split into two camps. One continues to model 3I Atlas as an extreme, but still natural object. The other has stopped pretending. Because the more data arrives, the more impossible it becomes to frame this within known physics. The lack of spin, the plume's directional stability, the propulsion-like acceleration. These are not quirks, they are characteristics. And in engineering, characteristics imply design parameters. Think about that. A natural object that obeys performance thresholds better than most spacecraft. There are no signs of decay, no tumbling, no uncontrolled jets, just stability, symmetry, and subtle course correction. If this is technology, then it's masterfully disguised, not as a machine, but as a phenomenon. One that knows it will only be understood by those advanced enough to see what it's hiding in plain sight. Here's the paradox that now haunts the brightest minds in astrophysics. If 3I Atlas is observing us, it's doing so by forcing us to observe ourselves, our calculations, our doubts, our patterns of curiosity, the way our instruments struggle, the way our theories collapse. That may be the point. Because true intelligence doesn't necessarily beam signals across space. It plants disturbances, just enough to see who notices. And once someone looks closely, the trap is set, not in violence, but in revelation. The more we study 3I Atlas, the more we expose what matters to us, what we prioritize, what we publish, what we fear, what we ignore. And in that feedback loop, we become the data, not by force, but by nature. As if the object is saying, I don't need to talk. You'll show me everything by how you try to understand me. There's one more theory circulating, not among official circles, but in the private messages between researchers who don't dare speak it aloud. The idea that 3I Atlas is not here to send us a message, or even to test us, but to trigger something. Not an explosion, not an invasion, but a cascade, a shift in perception, a pattern recognition so profound that it breaks the walls between disciplines, between physics, philosophy, biology, and cosmology. As if 3I Atlas is a kind of cognitive catalyst, engineered not to change space, but to change minds. It's the perfect delivery system, unthreatening, beautiful, unexplained. And its payload isn't data, it's doubt. Doubt that ripples outward into innovation, into danger, into paradigm shifts, like a cosmic domino placed gently in front of a civilization that has just begun to open its eyes, and we're the ones reaching for it. Here's the final twist. The closer we get to understanding 3I Atlas, the more we realize we might never understand it. And that's not failure, that's design. Because maybe its goal was never to be solved, but to be questioned forever. To haunt our textbooks, our algorithms, our late-night observatory logs. To become the quiet anomaly that scientists cite for generations, the one that pushed them to dig deeper, think stranger, and look longer. And in that sense, it achieves something no transmission ever could. It becomes a permanent question embedded in the evolution of our species. The kind of question that doesn't close doors, it opens them. Slowly, quietly, irrevocably. It came without warning. No lights, no sound, no message, just a trail, a shape, a contradiction. And in that contradiction, it did something extraordinary. It forced us to confront what we consider natural. It made our equations uncomfortable. It made our certainty uncertain. Because what kind of object accelerates toward the sun when it should flee from it? What kind of comet sheds nickel without iron, whispers thrust without ignition, and follows a path so elegant it might as well be choreography? The answer? Maybe it's not a comet. Maybe it's not a probe. Maybe it's not even a thing. Maybe it's a question. One engineered not to deliver truth, but to measure how we seek it. And in chasing it, we've revealed more about ourselves than about the object. We've shown that we are curious, that we question patterns, that we recognize asymmetry, intention, and silence that lingers a little too long. And maybe that's what it came to see. So now, 3I Atlas is leaving, drifting back into the dark it emerged from. But it leaves something behind. Not metals, not data, a mirror. Because in the end, the object may vanish, but the question it asked us will echo forever.